welcome to IQ online classes. So today we are going to do momentum. This is the one engineering science to physics. So I'm going to do this topic in question forms. So what is momentum? So question number one is what is momentum? What is momentum? What is momentum? So momentum is just simply the product of mass and what? And velocity. So it's just a product of mass and velocity. Product of mass and velocity. So this is just a product of mass and velocity is what we call momentum. And this momentum will be represented by letter what? By letter P. P. So this momentum will be represented by letter P. So meaning P is equal to what? mv, which is mass times what? Times velocity. So this is what we call what? Momentum. So let's talk about Newton's second law of motion. So Newton's second law of motion states Newton's second law of motion. Second law of motion. So state Newton's second law of motion. So Newton's second law of motion states that the change in momentum of a body is directly proportional to the unbalanced forces and takes place in the direction of the force. So the change in momentum of a body, the change in momentum of a body is directly proportional to the unbalanced force and takes place in the direction of what? Or the force. Or the force. So the change in momentum of a body is directly proportional to the unbalanced force and takes place in the direction of what? Force. So we know that Newton's law of motions deals with the forces. So we know that Newton's law of motions deals with the forces. Let's talk about this one. Let's talk about the equation for force. So we know that force is equal to what? Mass multiplied by what? Acceleration. So here we know what is the formula for acceleration. We know that we find acceleration by acceleration equals to v. Final velocity minus what? Initial velocity over what? Over t. So where there's a, let's try to put this. We see what we get is b. F is equal to mass multiplied by v minus u over what? Over t. So it will be F is equal to this one multiplied by this one, mv minus this one multiplied by this one, mu over what? Over t. Over t. So what is mu minus, what is mv minus mu? This is the change in momentum. So this is the final momentum, the initial momentum. So the final momentum minus the initial momentum is what we call the change in momentum. So it will be F is equal to what? The change in momentum over what? Over time. Over time. So according to this now, Newton's second law of motion states that the change in momentum of a body is directly proportional to the unbalanced force and takes place in the same direction of this force. From here, what if we decide to cross multiply here, we put a 1 here, we cross multiply here to be Ft is equal to what? Change in momentum. So what is Ft here? What is this Ft here? So this Ft here is what we call impulse. Impulse. And this is what? Change in momentum. So this is impulse. Ft force times time is what we call impulse. And change in momentum is this. So what is an impulse? How can we define impulse? So impulse is just the rate change of momentum. So impulse is the rate change of what? Momentum. So impulse is the rate change of momentum. You can see here Ft, force times time is impulse. So you can see that impulse is the change in momentum. So impulse is the rate change of what? Momentum. So that's how you define impulse. Okay. So let's proceed here. Let's proceed here. Let's proceed. Let's proceed here tomorrow. Okay. So from here, what should we talk about? So let's talk about the law of conservation of linear momentum. Okay. This is 4. State the law of conservation of what? Of momentum. State the law of conservation of linear momentum. So what does this state? So this states that the momentum before collision is equal to momentum after what? Collision. So the momentum before collision is equal to what? Is equal to the momentum after collision. So the momentum before collision is equal to momentum after what? After collision. So what do we mean by this? So the momentum before collision, we're talking about the initial momentum. So meaning the initial momentum is equal to the what? To the final momentum. So let's say here we have two bodies here. They collide together. We have two bodies. Let's say you have body 1, you have mass 1, multiplied by initial velocity 1 plus mass 2 multiplied by initial velocity 2 is equals to what? So this is before collision. So you have the mass 1 here, body 1, plus body 2 before collision, before they collide, before they hit each other. Then is equal to what? Mass 1 multiplied by final velocity 1 plus mass 2 multiplied by final velocity what? By 2. So this is the meaning of this statement. The momentum before collision is equal to momentum after what? After collision. Okay. So this is the law of conservation of linear momentum. So now let's talk about the 3 types of collision. State the three types of what? 3 types of collision. So state 3 types of collision and explain them. So state 3 types of collision and explain them. So we have the first type of collision here is what? Inelastic collision. So inelastic collision. What is this collision? So inelastic collision is a type of collision where bodies stick together after collision. So it's a type of collision where bodies stick together after collision. So here, bodies will stick together after collision. Stick together after collision. After collision. So this is a type of collision where bodies stick together after collision. So meaning the bodies will stick together, the other body will mate inside the other one. So the next one is what? Perfect elastic collision. Perfect elastic collision. So what is perfect elastic collision? So this is the type of collision where both momentum and energy is conserved. So both momentum and energy is conserved or are conserved. Okay. So this is a type of collision where both momentum and energy is conserved. So this type of collision is usually found in small and tiny particles like ions, molecules, you have atoms here. So this one is usually happening in very small particles. They're very small particles. So let's go to the next one or the last one. Let's go to the next one or the last one. Let's go to the next one. Let's go to this one, next one. So the next one is same or partial elastic. So let's say same, in some book is partial elastic, same elastic what? Collision. Same elastic collision. So what is this same elastic collision here? What is this same elastic collision? So this same elastic collision is a type of collision where bodies won't stick together after collision and some energy will be lost. So here, bodies won't stick together after collision. Don't stick together. Stick together after collision. After collision. And here some energy is lost and some energy is lost. And some energy is lost. So bodies don't stick together and some energy is lost. So the perfect example here is the ball and the ground. So when the ball hits the ground here, it won't stick to the ground, it will again bounce back. So after hitting the ground, some energy will be lost. As it is going up, it will go with a certain speed to reduce in speed. So these are the three types of collision. These are the three types of collision. Okay, so what's the next question? So the next question here, let's say, what is the coefficient of restitution for each type of collision? So, what is the coefficient of restitution for each type of collision? So I have these three types of collision, and each has got its own coefficient of restitution. And what is the coefficient of restitution? So the coefficient of restitution is simply the ratio of the final velocities to initial what? To initial velocities. So you will see when you start answering big questions and how we make the formula for coefficient of restitution. Okay. So for inelastic collision, say this. For inelastic collision, for inelastic collision, the coefficient of restitution is 0. You see the reason why. 0. For perfect elastic collision, the answer is what? 1. You see the reason why. For partial semi-elastic collision, for semi-elastic or partial collision, the coefficient of restitution is what? Anything less than what? Less than 1. So, less than 1. So it should be less than 1. So, 1 should be greater than the coefficient of restitution I. Or in simple terms, let's say, it should be less than what? Less than 1. That is 0.5, 0.8, anything less than 1. But for perfect elastic is 1. For inelastic is what? Is 0. So you see the reason why this one is 0, this one is 1, that one is what? Less than 1. I'll show you. Okay. So these are the definitions you need to understand. You need to understand the definitions. You need to understand these questions here before you start solving the actual momentum. So you need to understand this. You need to understand this because they open your mind before you start solving questions. So let's go to the actual momentum now. We'll start with this type of collision, which is inelastic collision. I want to explain it and give you all the formulas that you need to use when you answer the questions on inelastic collision. Okay? Okay. So let's start with inelastic collision. I'll explain them one by one. Inelastic collision. So let's start with inelastic collision. So we know that this is a type of collision where bodies stick together. So when bodies stick together, so what is the normal equation for momentum? So the equation for momentum is, for example, I have two bodies. So say to be mass of bod 1 multiplied by the initial velocity of bod 1 plus mass of bod 2 multiplied by initial velocity of bod 2 is equals to the mass of bod 1 multiplied by the final velocity of bod 1 plus the mass of bod 2 multiplied by the final velocity of what? Of bod 2. Of bod 2 there. But on this inelastic collision, we are being told that after collision, the bodies will stick together. So if bodies stick together, meaning they will only have one final velocity. They only have one final velocity. They have the same final velocity. So meaning the equation will be like this to be m1 u1 plus m2 u2 b equals to, you need to factor out the velocity here. So it will be v1 and what? And 2 opening, then you remain with what? m1 plus what? m2. M2. So this is an equation that you'll be using when bodies stick together. This is the equation you'll be using when bodies stick together. So this is the equation that you'll be using. So meaning, if they stick together, they only have one what? One velocity. And in a question, when you are told to find the final velocity, so meaning it will only be one velocity because they stick together and they move together that velocity. So when you want to find this velocity, just make V the subject of formula. So it will be V is equals to, you divide both sides with this one, m1 plus m2. Maybe this side say m1 plus what? m2. So meaning V is equals to m1 u1 plus m2 u2 over m1 plus what? Plus m2. So this is how you find the what? The final velocity. This is the final velocity here. So because they stick together, they only have what? One velocity here. So this is an equation that you are using. Okay? This is an equation that you are using. So this is for inelastic collision. So this is for inelastic collision. So let's do for perfect elastic collision. So for inelastic collision, stick to this equation. Stick to this equation here, this equation here. This is the equation that we'll be using. This is your tool, this is your gun. So let's go to perfect elastic collision. So let's go to perfect elastic collision. So let's go to perfect elastic collision. This is perfect elastic collision. So perfect elastic collision. So perfect Dirac collision is the type of collision where both energy and momentum is conserved. So both energy and momentum. So meaning we need to involve the equation for momentum and the equation for what? For energy. So what is the equation for momentum? So say mass of body 1, U1 plus mass of body 2, U2 is equals to mass of body 1, final velocity of body 1 plus M2 V2. Like this. So this is the equation for what? For momentum. This is the equation for momentum here. So what about the equation for energy? So here we use kinetic energy because after hitting each other, or when objects hit each other, they will be moving, they will continue moving, so there will be motion there. So let's use for kinetic energy. Kinetic energy will be half m1 u1 squared plus half m2 u2 squared be equal to half m1 v1 squared plus half m2 v2 squared. So this is the equation for momentum. This is the equation for momentum, this is the equation for what? For energy. So because both momentum and energy are conserved in this type of collision, we need to solve this equation what? Simultaneously. Okay. So the first thing, let's cancel these halves. This. So this will cancel this one. This will cancel what? This other one. So meaning here remaining what? M1 U1 squared plus M2 U2 squared be equal to M1 V1 squared plus M2 V2 squared. So this is the equation after we cancel these halves. This is for energy. For momentum, let me bring it down here. Okay, before I even bring this one down, what if we decide to bring these with my M1 this side and this with my M2 taken the other side? So let's do that. So the M1 U1 squared minus M1 V1 squared be equal to M2 V2 squared. This one will jump minus M2 U2 what? U2 squared. Okay? And again, here let me factor out M1 this side, so to be M1 open will be U1 squared minus V1 squared. I cross B equal to, I factor out M here, M2 V2 squared minus U2 squared. Something like this. This is U2 squared. Okay? So this is the equation now, the simplified equation for what? For energy. Okay. Let's do the same for this equation for momentum. Let's do the same for this equation for momentum. Let this with M1 come this side, this with M2 they go the other side. So it will be M1 U1 minus M1 V1 be equal to M2 V2 minus M2 U2. Something like this side. So meaning this is for what? For momentum. For momentum. Okay. So let's do the same. Let's factor out M here. So it will be M1 U1 minus V1 equals to M2, we factor out here, this will be F2 minus V2 minus U2. Okay? So we have simplified this one, is still momentum. Still momentum, this one. Okay? So let's bring these two equations here. Let's bring these two equations here. We see how we solve them. So we see how we solve them. Or let me just bring them on top here. Let me bring them on top here. Let me just bring them on top here. Okay. So let me bring them. So the equation for energy is this one. So say M1 U1 squared minus V1 squared B equals to M2 V2 squared minus U2 squared. What about for momentum? This one, B. M1 U1 minus V1 cross B equals to M2 V2 minus what? U2. So this for what? For kinetic. Okay, no, this is for momentum. This is for momentum. So let's solve these two equations simultaneously. So let's solve these two equations simultaneously. Let's solve them simultaneously. Let's solve them simultaneously. Let's solve them simultaneously. Let's solve them simultaneously. So let's solve them simultaneously. Okay, so if you solve them simultaneously, this one will go, which is 1. What about U1 divided by U1 squared? When you divide, so it will be 1 will go, then it will remain what? U1. What about this one? Divide by this one. So negative divided by negative, we have what? Positive. Then V1, V2 squared divided by V1, which is what? It should be just V1 like this. B equals to this and this will go. Here it will be what? Just be V2. This one, negative, negative to go at positive. This one will go. Just remain with 1 to go at U2. So this is the equation that we'll be using when solving questions on perfect elastic. So this is the final what? Final equation. So this is an equation that we are looking for. So this is the equation that we are looking for here. So this is the equation that we need here. Okay. So this equation. So on this type of perfect elastic collision, you need this equation as the first equation, and the second equation that you need is the equation for momentum itself, which is M1 U1 plus M2 U2 b equals to M1 V1 plus M2 V2. This is equation 2. So you need these equations. These are your guns. If you just understand these two equations, you are done. You are done. You are done with momentum. If you just understand. So on perfect elastic collision, these are the two equations that you need. These are the two equations that you need. You'll see how we use them when you're solving questions. It's simple and straightforward if you understand these two equations. Okay. So before we even move to the next one, I want to explain the coefficient of restriction here. Let me get the same equation. The final equation say U1 plus V1 equals to V2 plus what? U2. Okay. What if I decide these my final velocities, they go this side, and these my initial velocities, they go that other side? So I have what? V1 minus what? V2 b equals to, is it U2? U2 minus what? U1. Okay. So from here, what if now I decide to put this V in front here? Let me bring this V2 in front here. So it will be negative V2 minus what? V1. I've not changed anything. This one and this one is negative V2. This one and this one will be positive V1. B equal to what? U2 minus what? U1. U2 minus U1. What if now from here I decide to divide both sides with this? U2 minus what? U1. U2 minus what? U1. So this and this will cancel here. What is the final equation here? So the final equation here will be negative V2 minus V1 over U2 minus what? U1 is equals to what? Equals to 1. Okay, it's equals to 1. So what is the meaning of that one? So this one is telling you that the coefficient of restriction for this perfect elastic collision is what? It's 1. It's 1. That's why I said for perfect elastic collision equals to what? Equals to what? To 1. This is this one. Okay. So the formula for coefficient of restriction, where there's 1, let's put E representing the coefficient of restriction. So it will be E is equals to negative V2 minus V1 over U2 minus what? U1. So this is the equation of coefficient of what? The coefficient of distribution. So meaning here the coefficient of distribution is equals to what? Equals to 1. Equals to 1. But we said for inelastic collision equals to 0. Why is it 0? So we said the final velocity there after collision, because they will stick together, and we said they only have what? One final what? Final speed. They only have one final speed. So V2 and V1 will be the same. What if we say the answer is maybe after they stick together, the final velocity is what? Let's say the final velocity is what? Is 6. Let's try to replace 6 here on top. We see what we get. With 6, we say they have the same. So let's say negative 6 plus what? 6. What is the answer? Negative 6 plus 6. It's 0. It will give you 0 because they will be the same. That's why it's what? It's 0. When you press 6 here, it will give you 0. Even when you press any value here, as long as they're the same, they'll give you what? 0. That's the main reason it's called perfect elastic collision is what? 0, which is inelastic collision is 0. It's 0. So these are the equations that you need on this. These are the equations that you need on this. So if you just understand these simple equations, then you can answer any question on what? On momentum. So let me try to explain a ballistic pendulum. Let me try to explain a ballistic pendulum here. So let me try to explain a ballistic pendulum before I leave here. So let me try to explain a ballistic pendulum here. Let me try to explain a ballistic pendulum. A ballistic pendulum here. How does it work? Okay, let me try to explain the ballistic pendulum. So let me try to explain the ballistic pendulum. So for example, you have a bullet and a block. You have a bullet and a block. So a bullet will hit the block there using a bob, using a pendulum. So after hitting there, they say maybe it sticks inside the block and they move together at a certain speed. So here I'll just go direct to the formulas. So the formula that we use there, they say maybe after hitting the block there, it embeds inside, they stick together and they move together to a certain height. As they are moving together there, meaning there's motion, meaning there's what? Kinetic energy. When they reach a certain height, meaning there's what? Potential energy. So this is the equation that will be used for ballistic pendulum. And because they stick together, they'll have what? The common velocity. So this is how you make the formula for the common velocity. So it will be kinetic energy before collision plus the potential energy before collision. Potential energy before collision is equals to what? Kinetic energy after collision plus the potential energy after what? After collision. Right? After collision. So this is what we use. So after hitting each other, or when a bullet is moving there, there's only motion. So meaning there's only kinetic energy, there's no what? Potential energy. So meaning this side before collision will remove the potential energy, remaining what? The kinetic energy. And this side, after they move to a certain height, when they reach that certain height there, meaning there's only potential energy, because potential energy is just the energy due to position. So meaning there will only be potential energy, there are no what? Kinetic energy. So meaning here will remain the kinetic energy, only remain what? The potential energy. The potential energy. So from here, what is the formula for kinetic energy to be? Half mv squared B equal to, what is the potential, what is the formula for potential energy, which is what? Mg what? Gh. Okay, so mgh. So from here, our main goal is to find this v, to make v the subject of formula, which is the common velocity after a bullet hits that what? Block. So meaning here we divide both sides with this. So meaning this and this will go. Then we'll remain with what? V squared being equals to. So this and this will go. Then this one, if you want to multiply the interchange, this one will go up, this one will go down to be G, H multiplied by 2 over what is 1, K. Then from A to B, V squared equals to what? 2G what? 2GH. Then our main go on to remain with V, so we square root both sides to be V is equals to what? The square root of what? 2GH. 2GH. So this is the equation that we use to find the what? The common velocity. To find the final velocity if they stick together. This is the formula that we use only ballistic pendulum line. So this is the equation that we use if they stick together. You need to find the what? The common velocity. You need to find the common velocity. So in some questions, what they will do, they will ask you to find the initial velocity of what? Of a bullet before hitting the what? Before hitting the block. Before hitting the block. But you know that, so meaning this side here, before collision, because before collision, for example, if a block is just at rest there, then the bullet there is moving. Is moving. So how what? Mass 1, which is mass of the bullet, multiplied by initial velocity 1 plus mass 2, multiplied by initial velocity 2, being equal to what? So we say these things, they stick together, meaning we factor the what? The velocity, which is m1 plus what? m2. m2. So what is this v? In this case, this v on a pendulum will be what? The answer that you get here. That will be this v. But for this one, we have been in a question if you are told that the block is for a block, if the block was at rest, so meaning the initial velocity is what? 0. So meaning this entire thing will go, then will be m1 u1 equals to v open m1 plus what? Plus m2. m1 plus m2. Plus m2. Then in a question you are told to find the initial speed of the bullet, which is u1. So we can make u1 is subject of formula over what? m1 over what? m1. This and this will go. u1 is equals to v m1 plus m2 over m1. So this is the equation that we use to find the initial speed of a bullet before collision. So this is the equation that we use. So we need these equations here. So the first equation that you need is this one to find this common velocity, which is v, and you need also this to understand this equation there, so that you just replace the values. What is this v? The v is the common velocity, replace it here. What is the mass will be given in the equation? This mass will be given in the equation, and this mass will be given in the equation. You will just simple grade 1 mathematics to just divide. So see you in the next video where we'll solve all types of questions on momentum. Thank you.